Good day everyone, my name is Nico Nathaniel Esolfanta, and in this video, I'll be teaching you the law of exponents. I'll be giving you some examples in each law so you can further engage yourself in this lesson. Let's get straight into it. But first, let's briefly discuss what an exponent is. Exponents, also known as powers, are values that show how many times to multiply a base number by itself. For example, x over 4 tells us that we multiply x by itself 4 times. There are 7 laws of exponents, all of which will be tackled in this video. With each law, I'll show an example that you can use as a reference. Let's start with the first law on this list. The first law of exponent states that any number with an exponent of 1 will remain the same. An example would be 28 over 1 and a over 1. Both of these examples would remain the same value since the exponent is 1. The second law of exponents states that anything with an exponent of 0 always equals 1 when simplified. 350 with a power of 0 becomes 1 due to this law. Even variables such as x with the power of 0 and s with the power of 0 are affected by this law. The third law of exponents states that whenever you have a negative exponent, you must take the reciprocal of the number to simplify it. This means that when we have a number such as 3 with the power of 2, we first get its reciprocal, which is 1 over 3 with the power of 2. After which we can then simplify it to 1 over 9. This works the same way with variables, with a with the power of 12 resulting in 1 over a with the power of 12. The fourth law involves multiplying variables with different exponents. When we multiply two of the same variables with different exponents, all we have to do is add the exponent values. For example, x with the power of 20 multiplied by x to the power of 15 would equal to x to the power of 35, since 15 plus 20 equals 35. This also works for numbers with 2 to the power of 2 multiplied by 2 to the power of 10 would equal 2 to the power of 12, which is then simplified to 4096. The fifth law of exponents works similarly with the fourth law, only this time we are looking into division. When we divide two of the same variables with exponents, we will find the difference of the two exponents with a minus b, where a is the exponent of the numerator and b is the exponent of the denominator. X to the power of 12 over x to the power of 9 becomes x to the power of 3 due to this law. Another example is 2 to the power of 25 over 2 to the power of 23, which would equal to 2. The sixth law of exponents states that when an exponent is raised by another exponent, we should multiply both exponents to solve them. For example, if we have x to the power of 2 to the power of 3, the final answer would be x to the power of 6, since 2 times 3 is 6. Another example would be 3 to the power of 2 to the power of 4, which is simplified to 3 to the power of 8, which can be simplified further into 6561. The final law of exponents states that if an exponent is outside of a parenthesis, we distribute the exponent to all the variables in the parentheses. For example, in the problem, open to close parentheses, 6x minus 3y to the power of 5, solving it would look something like this. Distribute the exponent 5 to all the variables, which would leave us with 6 to the power of 5 multiplied to x to the power of 5 minus 3 to the power of 5 multiplied by y to the power of 5. When simplified, we get an answer of 7,776 multiplied by x to the power of 5 minus 243x to the power of 5. That's all I have for you today. Again, my name is Nico Nathaniel Esolfanda, and thanks for watching.